This video concerns the technique of weighing by difference. So when you're weighing by difference, what you are trying to accomplish is to obtain a mass of solid that is accurately known. For instance, in your lab manual you might see accurately weigh approximately 2.3 grams of cupric chloride. What that means is you want to accurately know the mass, but you want it to be somewhere within the vicinity of 2.3 grams. That doesn't mean that it has to be exactly 2.3 grams. So you're not trying to attain 2.300. Within 10% is generally sufficient to have any experiment go as planned. So we want to attain somewhere between 2.1 to 2.5 grams, but we want to know exactly what that mass is. So the instrument we use to obtain accurate masses is an analytical balance. So an analytical balance has enclosed doors, and that reduces air currents, which allows the mass reading to be more stable over time. So the first thing you do when you go to an analytical balance is to open one of the doors, generally the side that you're most comfortable with. Take a brush and just clean the area around the balance, and then gently clean the balance pan, which is just in the center. This is especially important if the person before you left a mess on the balance, but we'll talk about tidying at the end. If there is actually any solid residue there, it should be placed into a solid waste container. So when you're ready to continue, ensure all the doors are completely closed, and then you want the reading of the balance to show 0. At this point it just has some arbitrary reading. In most balances there's a bar which you depress, and the balance will then zero itself. Sometimes it might say tare, sometimes it might say 0. In this case it's just a bar. If it doesn't work the first time, you might have to do it a second time. So now that it's showing all zeros, we'll take the vessel that we're going to weigh our solid into, in this case a beaker, and we're going to place it on the center of the balance pan. And again, it's important to close the door. Once the reading has stabilized, write the value down directly on your data sheet. Sometimes this takes a minute or two. Okay, so now that it's stabilized, if the last digit is wavering a little bit, that's okay. 27.225.7. So at this point you can take out your beaker, and we want to add 2.3 grams to the beaker. So currently the beaker weighs 27.2257. In the end, we want the beaker and the solid to weigh a total mass of 27.22 plus 2.3 grams. So that's 29.5. And again, anywhere within 0.2 of that number will be fine. So 29.3 to 29.7. We always take the beaker out to add our solid so that we don't make a mess on the analytical balance, because the analytical balance is a very precise and expensive instrument, and having solid get underneath the balance pan can decrease those very precise factors. So what I have here is cupric chloride crystals. It's important that if you are going to use a spatula or a scupula, that you always ensure that it's completely clean and dry before you put it in there. And so just take a little bit out, put it into the beaker, and since you have no idea what 2.3 grams might look like, you will then put the beaker back into the balance and get an estimate of how close you are to your final reading. So right now, looks like I've added about 0.8 grams if I do the subtraction in my head. So we want to add more than that. So again, taking it back out. I'll probably add 2 scoopfuls and putting it back in. So right now my balance is reading 30.5 grams, and what you'll notice is that we were supposed to attain 29.5 grams. This is a little bit too too far outside of the allowed 10% error. So what I'll need to do is take some of this solid out in order to decrease the mass. So when you do that, you never put the solid back into the original container because it risks contaminating the container. Instead, take a waste container and then take some of the solid out and just place it in the waste container until you think that you've taken out the sufficient amount. And it is a bit of a guessing game, but again, remember you're not trying to attain an exact number, just a range of numbers. And my balance has shifted a little bit in terms of its number right here. So what I'm going to do is close the door again and just make sure that it is zeroed before I put the beaker back in. And again, not quite there because we have 30.0 and we're looking for somewhere 29.5, 29.7. So we have to take a little bit more out. So you can see that although it's not a very fast process, it's not taking us a huge amount of time in the sense of going back and forth, back and forth. You can do this actually pretty quickly once you get used to it. It's not as tedious as it first looks. So now we have 29.87, so again, repeat. So just a little bit more should do it. Making sure our balance is zeroed. Okay, so now we have 29.78, and that is within 10% of the 29.5 that we were looking for. So once that stabilizes, we're going to write down that number. And it's flipping back and forth between 2 or 3 numbers right at the very end. So we'll just go with the middle number. So 29.7805. So what you'll notice on my table here is that I have the mass of the empty beaker. I have the mass of the beaker plus the solid. So if I subtract these numbers, what I'll get is the mass of the solid that was added to the beaker. And that becomes 2.5548. Keeping in mind that the first number here has 4 decimal places, the second number has 4 decimal places, so then when you subtract, the third number will have 4 decimal places. One important fact that's missing from these numbers is the units. So you can choose to put them after each of the numbers, or you can choose to just put them above the table. It's your choice, but it is important that you always have the units in there. So notice what we were trying to attain was approximately 2.3 grams, but we know we have exactly 2.5548, which is about 10% away from 2.3.